All right, well, let's get started. People will jump on if they get in. Let me pin my video, make sure it has a better recording than last week. Okay, so before we start, we were talking a little bit earlier that I am towards the end of my pregnancy. Baby could come at any time, really, or baby could come in 4 weeks. Who knows? I don't think my doctor will let me go that long. But anyways, Robert is here, and he is going to take over for me when I cannot teach anymore. So be looking out for an email from him. There'll be a new Zoom link meeting from him as the administrator host of the meetings. So be on the lookout for that. He'll be taking over for me sometime, maybe in the last 2 classes. I'm hoping I'll still be able to do next week, but we'll see. And then I also, Robert is going to take over and do CoNav1. So CoNav1 will be directly following this class of CoNav1. So at first we weren't going to do that class, but Robert is going to take that over as well. So if you guys are interested in doing some more set and drift tides and current calculations to, in this CoNav1, we're kind of putting ourselves in that perfect environment of we're going to stay on this course line, but in reality, we get set off course and have to make adjustments. So we go over a lot of that set and drift, how to calculate tide in the 4-week CoNav1 class. So that's going to be directly following this class. So
it may be on a different night, however. We're not sure yet.
Okay.
So stay tuned, watch out.
Stay tuned for more information. Cool. Yeah, that's my announcements for today. We are going to go over speed, distance, and time. And then next week, we're going to kind of put together our compass error that we learned last week and our speed, distance, and time, and really dive into the DRs and plotting. So we're going to touch base on it tonight and then dive into it next week. Did anybody have any questions before we wanted to get started? I know a couple of you guys. All right. Well, let's jump into it. Let's bring up the PowerPoint. Okay. All right, so we're good on seeing the PowerPoint, right? Okay. I always like to double check before I start jabbering on. So today's class is going to be diving back into our math skills, our high school math skills of formulas and moving around time and math. And really, some students are like, oh yeah, I got this, but it's the little tiny, especially those Coast Guard test takers, it's the little tiny mistakes that are so easy to make. Doing that mental math in your head, you can make shortcuts and make a lot of mistakes that way. So, I mean, you'll definitely see me doing mental math in my head, but you can use a calculator, whatever you want to help you out through this. So just a lot of math today, so be prepared for that. All right, so distance, time, and speed. Those are our 3 topics. So first we're going to start out with the units. I always like to have units attached to a number. Just a good habit to get into in any math class, whether you're doing in physics or chemistry or whatever, that you always want to put your unit on the number. So you don't just have a random number floating around. You want to give it an identity with a unit. So for distance, the units that we will be using are nautical miles. So nautical miles are different than statute miles, right? I think I touched on this earlier. I don't know where statute miles came in, but that nautical mile is exactly 1/60th of a degree of latitude. So if you divide up, the whole world into 180 degrees, we have 90 degrees of latitude in the north, 90 degrees of latitude in the south, and 1 degree has 60 nautical miles in it. So 1/60th of a degree is a nautical mile, which is equal, for our American purposes, to that 6,076 feet, where the statute mile is a little bit smaller. It is that 5,280. So just to keep that in mind, some places, will have miles per hour or knots. If you have miles per hour, they're talking about statute miles. If you have a knot, it's talking about a nautical mile, which I'm going to get into. But yeah, nautical miles are different than statute miles, and a nautical mile is equal to 1 minute of latitude. So that's our distance. For time, we're either going to use hours or minutes. So we can't use both. It has to be in all hours or all minutes. So it's not going to be, an hour, 45 minutes. We're going to say it's like 105 minutes or 1.75 hours. And we're going to get into that conversion. But the time, we're familiar with minutes, we're familiar with hours, but it has to be one or the other. It can't be both units. So we're going to practice converting time. And then for speed, our unit is knots. And knot literally means nautical miles per hour. So just like on the freeway, you're going 60 miles per hour, that's 60 statute miles per hour. So on the water, you're going nautical miles per hour. So you're going 10 nautical miles per hour, which is just a little bit different than your statute mile. So just keep that in mind. So we have knots, hours or minutes, and then nautical miles. Those are our units of measurement that we're going to be using. Our formula our basic formula is distance of nautical miles is equal to our speed times our time. So D equals ST is our basic formula for calculating distance, speed, and time. Now, if you just have D equals ST, that time is in hours. For this class, we are going to put a 60 in front of it, and we're going to call it 60 D Street. That's the kind of the nickname that you'll hear me throw around a lot. So we have 60 times nautical miles equals speed times time, where that time is in minutes. So we've converted the time into minutes, not hours. And we've put the 60 over there. So we have our 60 D Street formula, and then our D equals ST. So they're the same formulas, just a different unit as t, time. So within this formula, 60 D street, we can move, going back to our algebra class or geometry, I don't know what it is, in high school, we can move around the letters to figure out what we're looking for. So if we are looking for speed, we want to get that S all by itself. So I want to know what speed is, but there's a T on this side of the equation. So in order to get rid of that T, or basically move it over to the other side of the equation, I have to do something to the equation. Now, whenever you do something to a math equation, you have to do it to both sides to make it even. So in this case, I'm going to divide by time on both sides of the equation. So it's still a valid equation. I haven't changed it very much because I'm doing the same thing to both sides of the equal sign. In this case, t divided by t cancels each other out. It equals 1. So if I, have 2 divided by 2, that equals 1. If I have 1 divided by 1, that equals 1. 1,500,000 divided by 1,500,000 equals 1. So that's why we can just cancel out the t's on this side, and we're left, we can't cancel anything out on this side. So we're left with 60 times distance divided by time equals S all by itself. So now we can solve for S. We can solve for that speed by plugging our numbers into this equation. So that is our final speed equation. If we're looking for time, we're going to do the same type of thing. Same thing. We have to do the same thing to both sides of the equal sign. So if I want time, I need to essentially get rid of that S. So I'm going to divide by speed on both sides of the equation. And these two S's, S divided by S, will cancel out. So I'm left with 60 times D divided by S equals T all by itself. So that's my final time equation. For distance, I want to get distance by itself, so I have to get rid of that 60. To get rid of the 60, you divide both sides, 60s cancel out, and we're left with D equals ST divided by 60. So we have 3 equations, one for distance, one for time, and one for speed. But really, I'm going to say the only one you really have to remember is our 60 D street. And then you could move around the equation whatever way you need to. So if you're going to do equations or equations, you don't have to memorize, all 3 different ones. You can just memorize 60 D street and move around the equation however you need to. So that is that. Any questions on those 3 equations? Make sense so far? Okay. So for those of you guys who don't like formulas, or that was super confusing, what I just said, we do have the magic circle, which is kind of like an equation, but maybe a little bit easier. I personally did not understand the magic circle for a long time. I'm more of a formula-minded person. I like the whole balance on side of the equal sign, but some people just get the magic circle and that's what they do. So both ways totally work. I'm gonna do both ways, the formula way and the magic circle way in class. So whatever way you do it, we can accommodate and do whatever which way. So let's dive in. For non-formula people, magic circle. you create a circle with 4 components, and you're going to put your 60 D street in it. 60 D on the top and then ST on the bottom. So we make our circle with our 60 D street. Our rules for our formula, are we going to multiply across? So we always multiply across. And then whatever missing quadrant we have, we're going to be missing something, whether it be distance, speed, or time. There's going to be one missing value. So whatever we have, whichever one is missing that we can't multiply, we're going to divide by. So we're going to jump into a couple examples here, but you first multiply whatever's are next to each other, and then you divide the other value. And that's how you get the missing value. So that's the magic circle. Now we're going to do a couple examples here using both the formula and the magic circle. So let's dive into that. So our first example is we have a speed of 15 knots. So that's 15 nautical miles per hour. Our time is 30 minutes. How far did I travel? So I'm traveling at 15 knots. How far would I have gone in 30 minutes? So I'm looking for a distance. So I have my 60 D street formula. I've rearranged it so that I have D all by itself. So I have D equals ST divided by 60. And I put in my numbers. My S is 15, my time is 30 divided by 60, and I get my 7.5. So that was just plugging in the numbers to the equation to get my distance. If I'm doing it by magic circle, I plug in my values into the quadrants. So I have my 60 up top, 15 and 30 are down below, and I'm wondering what my distance is. So again, my first step is always to multiply on the magic circle. First step is always multiply. So we're going to multiply our 15 times 30 and then divide with whatever value is left over. So even though 60 is above, you always multiply first and then divide by the other value. So again, it turns out to be the same. You can use either one, but that's an example. Let's do another one looking for a different value. Here we have speed of 8 knots. And we are going 2 nautical miles. How long will it take us to go 2 nautical miles at a speed of 8 knots? So we're going to do our 60 D street. We're looking for time, so we want that T all by itself. So I've rearranged the formula to get 60 times D divided by S. I'll plug in those values, and I get 15 minutes. So 60 times 2 divided by 8 gives me 15. So it'll take me 15 minutes to go 2 nautical miles at 8 knots. If I am doing magic circle, again, I just put in my values. So I put in 60 D street. My D was 2, my S was 8, T was a question mark. The two things that I have, I'll multiply first and then divide by the other value. So I get the same thing. Okay, one more example. This time we're looking for speed. So in our equation, I want to get S by itself. So I redo the formula to get S by itself, plug in my numbers, and I get my speed. For the magic circle, again, put in the numbers where they go. S goes question mark, T goes where the T is, distance goes in the distant quadrant. You multiply the two things that you have next to each other, and you divide by the other value. So you always get the same thing. Any questions on those formulas before we dive in more? Rearranging, working the formula. I feel like I did that pretty quickly.
Hello, I have a question.
Yes.
So if the T is given in hours, then you don't use the 60. I mean, that I know that's true. I'm just, so are you saying for all of our work, it's all going to be in minutes by definition?
Yes.
Okay.
So we would convert it to 60 minutes. We're going to convert our, so typically in,
but if the time is given in hours,
then you don't have to use, you can use that D equals ST.
correct?
Yes.
Okay.
So I'm going to say in the commercial industry, we use D equals ST. We don't do anything 60. We put our times all on a 6-minute mark. So even if we made arrival at, 1855, I would call it 1854, a multiple of 6. That way I get a solid decimal and I have just 1/10 of an hour. So I have a solid hour with 1/10 of a decimal. But more in that way, it's easier when you're making a calculation. Say you're going from, Japan to LA. You don't have like 100,000 minutes. You have a smaller number, right, in hours, and then you can convert that to days. For kind of our weekend warrior boaters style that a lot of us are doing in this class, we only are doing minutes. It's only going to take us 50, 45 minutes, half hour, maybe 120 minutes or something, 2 hours. So we're kind of do that minute section for a lot of the recreational boating that we do around here. But yeah,
Okay.
you're either going to do hours or minutes. So depending on what type of question you are trying to solve for, use your 60 or not 60. But you can't put minutes into D equals ST. It has to be hours. Okay. So where do we find this information? So sometimes it's not going to be exactly given to us, like my examples where I have speed equals question mark, time equals 45, distance equals 5. So sometimes we have to do our problem solving and figure out where to find this information. So typically our distance is going to be, or always our distance is going to be measured on the chart. So instead of saying you're going 5 miles, it might be what's your ETA to Avalon, right? So we have to figure out on our chart using our dividers, what is that distance to Avalon? Or what's our ETA to the Long Beach buoy? I have to figure out what the distance is. It's not going to say, exactly what the distance is. So there is that step of using your chart and your plotting tools to figure out what the distance is. For time, again, we're either going to use hours or minutes. And so if you have a desired ETA, again, most recreational boating, we're not going to have that deadline ETA that we're trying to figure out and adjusting our speed to. We're just going to go a certain speed and figure out what our ETA is, and it is what it is. Because sometimes adjusting speed isn't, an option for us. We can't fine-tunely adjust our speed like the commercial boats can. And speed is going to be our distance equals ST. It's our nautical miles per hour in knots. So that's how we're going to communicate our speed, by using our formula and getting our nautical miles per hour. Okay, so let's practice converting our time. So here we have 1 hour and 15 minutes. So if we want to go to whole hours, that is 1 hour and 15/60 of an hour to make it a whole. When I say whole hour, I mean the hour will, or the unit will only be in hours, not hours and minutes. So it's 1 hour and 15/60. So that would be 1.25. So 1 hour and 15 minutes, 1.25 hours. If we want to go to minutes, then we have the hours plus the minutes. So we have hours or minutes in 1 hour, 60, plus the extra 15 minutes will give us 75 minutes. So kind of going on Eric's question here, this is also kind of that, where does your brain go first when I say 1 hour and 15 minutes? Does it go to 75 minutes or does it go to 1.25? That kind of, how are you familiar? What's your, familiarity level of putting time into hours or minutes? So it's all going to be dependent on your comfort level and how you want to rearrange the equations. So if we have a larger number, like 6 hours and 36 minutes, we are going to, if we're going hours, that's 6 hours and 36/60. So we have 6.6 hours. Or we have a large minute number. So we have 60 times 6 to give us our minutes for the hours, plus the 36 gives us our 396 minutes. So sometimes when you see that number, 396 minutes, that's a harder number to visualize. How long is 369 minutes? Where 6.6 hours, you're like, okay, it's a little bit more than 6.5 hours, something like that. So I would say for longer times, it's a little easier to keep it in the hour format than minute format. But a lot of our times are already in minutes. So our last example here is 42 minutes. If I wanted to convert that to hours, I'd have to convert it to 42 divided by 60 would give me 7/10 of an hour. Now, if I'm just using my 60D street with my 60, with my minutes, there's no conversion at all. It's already in minutes. I have no hours. So it's just 42 equals 42 minutes. All right. How do we feel about converting time? Making sense?
I guess my question is, like, why do we have to do this? Like, if we're just planning a trip, say from here to Catalina or here to San Pedro or Point Furman or something like that, do we really need to do these conversions, or is it just kind of to help us with like our comfort level, I guess you were saying earlier?
So yes, in order to do the 60D street, any ETA formula, whether you're going from Newport to Avalon, we're going to use that 60D street, and it either has to be hours or minutes. It can't be both. So we're going to have to convert that time. We're used to saying, 1 hour and 15 minutes. We have to convert it all to hours or all to minutes.
Oh, I see. Okay.
So, yeah.
Go ahead. I have a question. This is Barbara. So, you know, that last example is 42 minutes. If that was 41 minutes and you were making several stops, you'd be off because, you know, you have the fraction isn't a perfect 0.7. So,
Correct.
I guess if you're doing short trips, you would do, well, that's what you said about commercial vessels. They're crossing oceans, so they use the hours. Okay.
And they're going to round to the nearest 6 minutes.
Right, right. So they don't have to have.
If you're doing hours and you have, I guess I'm going to say 30 minutes, that's just 0.5. But if you have 32 minutes, it's going to be 0.512 something. So like, I don't know what number it is. I'm just putting that out there. It's going to be a little bit more than 0.5, a little bit less than 0.6, because it's in between that 30 minutes and 36 minutes where we get that. So I guess my brain goes to fractions of an hour, and the whole 6/10 of an hour, but let's just keep it simple and keep things in minutes. So we have 75 minutes, 42 minutes. I think that's the way most people are going to look at it. But we will see.
The homework answers are in hours. Just a FYI on that.
The answers are in hours?
Yeah, I'm pretty sure. Let me see.
I think we convert hours in minutes.
Yeah, but when they ask you a question, let me see what's a homework question. Yeah,
Okay. We're gonna do it together, so we will find out. Okay. I guess I just want to say, yeah, we're going to practice with our 60 D Street, so we're going to convert things into minutes for most of my examples here. Yeah. Okay, our next math test here, topic, is going to be adding and subtracting time. So again, this is going to be a little bit different than our just basic addition, subtraction skills, because it is time. We are going to use that, military or UTC, not UTC, but that 24-hour time. So if you're not familiar with 24-hour time, there's no AM or PM. We go from, 0-100 hours to 2,300 hours. So we have, midnight through noon is going to be your same type of time style that you're used to. And then from noon on, instead of changing back to 1 and adding a PM, it's just going to go from 12 to 13 and then to 14, 15, et cetera, et cetera. And we don't have the dots. So we just have the time as 11:23. Then we have, I'm just looking at the examples here, 22:55. So that's going to be 10:55 p.m. if you wanted to go back to see what time that is. Doing this just makes it easier to add and subtract time. I guess, I don't know the real reasons behind it, but all of our times are going to be in that 24-hour or military time style. So with adding and subtracting time, you always want to put the later time on top, especially when you're subtracting. Just like when you're subtracting, you know, just numbers in general, we're going to put the bigger number or the later one on top, and then you subtract going down. So if we wanted to add these two times up, we're going to always start with the minutes or seconds, the smallest value. Just like regular addition or subtraction problems, we're going to start on the right. I like to put a little line down the middle, so I have that division of these are minutes and these are hours. So if I'm adding these two up, just what's 23 plus 12, I get 35. So that's done. And then I have my 11 plus 10, I get 21. So that one's pretty straightforward. For subtracting, again, we're always going to start with our smaller unit of the minutes or the seconds. In this case, it's just minutes. So we have 55 minus 30. What's the difference? What's the difference in these two times? 55 minus 35 gives us 20 minutes. And then we have the 22 minus 20 gives us 2 hours. So the difference between these two times is 2 hours and 20 minutes. If I wanted to add a certain time, value of time, so I want to add 1 hour and 25 minutes to 1545. Again, I'm going to start with the minutes. So I put my little line down and I get 70 minutes. But 70 minutes is not a possibility on our clock, right? Because we go to the next hour after 59 minutes. It goes to the next hour. So after 60 minutes. So how do I carry this over? I'm going to subtract 60 and I'm left with 10 minutes and I'm going to carry over 1 hour. So then I could add up my 15 plus my 1 and my 1 to give me a 1710. So from 1545, you know, I'm transiting 1 hour and 25 minutes. What time will I get there? If I add up the 45 and 25, I get a number bigger than 60, but I have to carry that over. So kind of like, you know, your basic algebra or I don't know, whatever math. You carry over the 1 or you carry over the second digit to the next column. So same kind of thing here. We're going to carry over our value to the next column. And we get 1710. Same type of thing if we are subtracting. Here we want to know what the time difference is between 9:12 and 8:23. So here I'm going to subtract 12 minus 23, but I can't do that because 12 is smaller than 23. So I need to borrow from the hour section. So I'm going to cancel out the 9 and the 12, and I'm going to put 60 minutes over here on the minute section. So I'm left with 08 and then 72. Which again, you know, isn't a time. We don't say, oh, it's 0872. We say it's 0912. But in order to do this math calculation, we're left with 08 on the hour side and 72 on the minute side. Then we can safely do our subtraction of 72 minus 23. Gives us 49 minutes. 8 minus 8 gives us 0. So the time difference between 8:23 and 9:12 is our 49 minutes.
Can I ask a question? I have a question.
Go ahead.
So I'm just how do we know that the 0823 isn't 8 minutes and 8 hours and 23 minutes? Is it how do we know that's a timestamp and not a amount of time?
So in our practice, you're going to get it as an actual kind of word problem and not just random numbers I'm throwing up there on the board for you. So you have, a departure time, a transit time, an arrival time, or a transit time, essentially. So I either put an H or an M next to it if it's a transit time, a value of time rather than an actual clock time. Or I do the little dash, not dot dot. Dot dot is confusing because dot dot can mean hours and minutes or a time of day. So I really try to avoid that that dot dot. I don't know what is that? Colon. I don't know what grammar.
Colon. Yes, that's a colon.
So yeah, I try to avoid that because I think it adds a little more confusion. You'll see me shorthand it as just a dashed line, or you could put the H and the M. But typically, I'm just doing some examples here of our adding and subtracting time, but you're going to have more information than this. It's going to be the values that you get in here are going to be, on the chart numbers that you're getting. So there will be that additional information of, is this a transit time? Is this a arrival? What kind of time are we looking at? So hopefully that helps. I'm going to leave this slide up and give you 5 or 10 minutes here to practice some adding and subtracting of time. So go ahead and grab paper, pencil, whatever you got, and practice adding and subtracting these times.
So the goal is to, like, we're kind of planning a trip and somebody says, okay, you depart at 12 o'clock or 1200 hours, 12 in the afternoon, whatever. And your transit time is 4 hours and 16 minutes. What time are you going to arrive?
Correct.
By adding these two different formats of times?
Correct.
Okay.
You've departed at noon. You've calculated your transit time to get you there will be 4 hours and 16 minutes. What's your ETA?
Okay.
And then the second type of question is, you arrived at this, or you departed at this time and you arrived at this time. How long did it take you to get there?
Oh, I see. Okay.
What's your transit time? Then you could calculate, your average speeds. And then estimated time of departure. Say I have, I need to make an ETA of 14:30. I've calculated that it's going to take me 2 hours and 12 minutes to get there. What time do I need to leave by?
14:30 minus. So that 2:12 in this format you're giving us is
2 hours and 12 minutes.
Just written in kind of a different way?
Yeah.
Okay.
So that transit time is just the hours and the minutes, just with a tacked line, not a colon.
Right. Okay.
Is that last one? Well, you're gonna go over these.
What was that?
That last one on the ET, estimated time of departure. That last one. Am I reading that wrong?
0138?
Arrive. Okay, never mind. Well. Oh, I see, I
You're
see.
gonna be,
I
you're gonna
got it.
be departing the
Okay.
previous day.
I got it, yeah. Okay,
Throwing a little sneaky one at you.
yeah, I see that. Okay.
Okay, so I'm gonna click through the answers here. So we have 12 plus 4 hours, 16 minutes. We do the minute section first. So we get 16:16 as our ETA, our arrival time. This guy we had to carry over. So we had that 72, we had to carry over a 1. So we get 12:12. We had to carry over on that ETA. For our time differences, our first one, 16:54 minus 12:45. That one's going to be pretty straightforward. On our second one, we do have to borrow. 30 minus 45 doesn't count, or we can't do that. So we do have to borrow. And we get 90 minus 45 gives us our 45 minutes. Estimated times of departure. We have our 14:30. Takes us 2 hours and 12 minutes to get there. So we need to leave by 12:18 in order to get there. If we want to arrive at 1400, takes us 36 minutes. We want to subtract, or we have to borrow, because we can't do 0 minus 36. So we borrow 60 and we get 13:24. So sometimes, you know, people just do it in their heads, but math-wise, that's the way it works. For a tricky one to the previous day, we start with the minute section. Can't subtract 46 minus 38, so we borrow our 1 and we get 0. That's not 60. That should be 98. Yeah, that should be 98. No, so 98 minus 46 equals 52. I did that right. That number's wrong. And then I have 0 minus 1, which we can't do that either. So we convert our 0 into 24 hours of the previous day minus the 1 gives us our 22:52 for the previous day.
What did you mean by that's a tricky one because it's a previous day? Like you're going from one day to the next? I didn't know what you kind of meant by why that's tricky. Or
just because of the numbers, it's the same math, but instead of, you know, because we can't do 0, 0 minus 1, we have to go to the previous day. So that is equal to 23 instead of a -1. We don't have like negative numbers. We're going to go. So if I was to write this out as an actual question, I would have the date on this as well. So if it was, you know, what's today? 5/12. So you say 5/12 at 1:38, but it's going to take me this much time, my departure time needs to be the day before, 5/11 at 23:52. 5/11 meaning the date, May 11th. Okay. So all of this slides really are just saying that we want to be, especially if you are plugging things into your phone or your calculator. I don't know where my calculator went. We can't just plug in, 1654 minus 1245. That our calculator, unless you have it in a time mode, which some calculators do, but your basic calculator is going to give you the wrong answer for that. That we have, our 60 minutes and our hours. So we have to do those separately when we're adding and subtracting time. I guess this one works that way, but our borrowing ones will not. Yeah, so we just want to be aware of when we're adding and subtracting time that we have minutes and hours. Okay. Let's put this into practice, and let's do assignment number 8 together. Why is this going crazy?
Assignment 8. Are we? Oh, second.
Really not finding my screen here. Okay, there it is. Kind of. Dare I push it one more time? Oh man. Give it something else to look at. All right, there it is. Assignment number 8. Okay, so let's start with number 1. So number 1, this is going to be our practice of doing our 60 D Street calculations. Number 1, at 11.6 knots, you're traveling for 4 hours and 14 minutes. What is the distance traveled in nautical miles? So I have a speed of 11.6 knots. I have a time of 2 hours and 14 minutes. And I am looking for my distance. So I'm going to do 60 D Street. But first, I need to calculate this time into minutes. So I want to calculate that, convert this into minutes. So I'm going to say 2 hours is 120 minutes plus the 14. gives me 1:36 minutes. So now I can plug this into 60 D Street. And I'm going to look for distance. So I get distance equals S times T
Isn't it
divided by
134 minutes?
60.
Yeah, it's 134.
34. Yes, you're right.
You're just testing us, right?
I'm just testing you. Thank you. And now I can plug in the values. I can plug in my S and my T. I have S and I have T. So I can plug those values in. D equals 11.6 multiplied by 134 divided by 60. So on my calculator, I'll just plug those numbers in. And I get a distance of 25.9 nautical miles. So I like to do the, does that make sense, check. If I am traveling at 11.6 knots for a little over 2 hours, so that's, nautical miles per hour. So I'm going a little over 2 knots or a little over 2 hours, a little bit less than 12. So it would be somewhere around 24 in my head. That makes sense of having a distance of 25.9. If I get like some crazy small number, maybe we added or multiplied when we sort of divided, something like that, crazy big number, one way or the other. I just like to do the, does the value of 25.9 nautical miles make sense in this question, I guess. Okay. Any questions on number 1? All right. There's number 2. It took us a time of 1 hour and 22 minutes to cruise a distance of 18.6 nautical miles. What was our average speed? So we want to know what our speed was over an hour and 22 minute time period. So we have our distance, and now I want to calculate what my speed is. So my first step is to put my time into minutes. So we have 60 plus 22 gives me 82 minutes, hopefully. And now I can plug it into my formula. So I have 60 D Street. I want S by itself. So I convert that. Actually, well, I already started this one. Next one I'll do the magic circle. Now I can just plug in my values, my D and my T. I have those values, so I can just plug in my numbers. 60 times 18.6 divided by 82 equals speed. Bring back my calculator. 60 times 18.6 divided by 82 gives me 13.6 knots is my speed. And I say, does that make sense? I check here. Took an hour and 22 minutes to go 18 nautical miles. Yes, 13, 14-ish. Knots makes sense. So that number is good. All right. Let's do number 3. Here we cruise at a speed of 14.3 knots for a distance of 24.6 nautical miles. How much time did it take? So in this case, we have our speed and our distance already in the units that we need, so we don't have to convert yet. We can plug it into our equation. So this time I will do the magic circle. So I have 60, 24.6. My S was 14.3. My T is my missing value. So I always multiply the two values that I have next to each other first, and then divide by the other value. So I will do 60 times 24.6 divided by 14.3. Gives me a time of 103. So I have 103 minutes as my time value, and I want to convert that into back to hours and minutes so I can have it more logical in my head here, or add it and subtract it to, you know, time of departure or something like that. So in order to figure that out, I'm going to minus 60, and I get 43. So I have 1 hour and 43 minutes as my time. Does that make sense? How do you guys feel about that one? All right. Okay, I'm gonna skip 4 and 5, or yeah, you guys can do 4 and 5 for homework. Let's do a number 6, kind of a ETA mixed with a 60D street. Okay, so this is gonna be number 6. All right, we want to cruise to a distant harbor to meet our friends for lunch at 1300. The distant harbor is 19.9 nautical miles away. The boat just came from shipyard, and you know will make a speed of 5.8 knots. Will you make it there in time for lunch? So we are looking for how long it will take us to get there. And we have a departure time of 10. So first I need to figure out how long it will take me to travel to the distance harbor, 19.8 nautical miles at a speed of 5.8 knots. So I'm looking for T. I will do my 60D divided by S equals T. Plug in my values to get 60 times 19.8 divided by 5.8, and that gives me my time. So I have 60 times 19.8 divided by 5.8 gives me, we'll round and say 205 minutes equals time. So 205, you can do this two ways to get it back to hours and minutes. You can just subtract 60 until you get a number smaller than 60. So I subtracted 63 times. So I'm left with 3 hours, 25 minutes. You could also, we had 205, you can divide that by 60. You're left with 3 point something or other. You could subtract that 3 and then multiply back by 60, and you get your 25. Either way, whatever way works for you, works for you. So our time is 3 hours and 25 minutes. So if we depart, our departure time was 10, our transit was 3 hours and 25 minutes. What is our ETA? I like to put my line through the middle, and I get, we're adding, so I get 25 and 13. And lunch was at 1300. So will I make it there by 1300? The answer is no, I will not. I will be 25 minutes late. All right. How do you guys feel about those practice questions? Okay. Okay. So before we take our break here, you can finish up assignment 8. Assignment 9 is 10 questions of the same practicing your 60D Street in a little, mini word question or mini little problem that they give you. So go ahead and do that one as your homework as well, just practicing that 60D Street formula to plug in for that. We are going to wrap up our slides and then do assignment number 10 together, which is going to be practicing the 60D Street on the chart in our intro to dead reckoning. But for the first two, assignment 8 and 9 are all the 60D Street and adding and subtracting that time. So pretty much just what we did here. Does anyone have any questions on that? Okay, let's wrap up our PowerPoint. and then we'll take a break. Okay, so we just did assignment 8. You guys can do assignment 9. Okay, so on the chart, we're going to practice what we call dead reckoning, or it's, deduced reckoning. It's basically just a calculated position where it's purely calculated, and we're using that 60D street to calculate this position. It's a great tool. We use our DR position for a lot of things in plotting. One, it's great backup if we don't have a GPS working or we can't get a visual fix. We can always DR. We can say, hey, I've been headed, due east for 4 hours now. This is generally speaking where I think I am. Maybe the wind pushed me one way or another, or, hundreds of different things, but I can say, this is my DR. This is just my calculated position, my guess. Instead of just saying, hey, I'm somewhere in the Pacific, I can say, hey, well, if I was traveling at, 10 knots, 4 hours later, I would be, 40 miles offshore, or something with a little more, information in there that we can use as our dead reckoning, our DR. So it's great for a backup if we don't have any other tools. And it's also great for giving ourselves a look ahead to say, hey, I'm going to be, crossing that traffic lane in a half hour, or I want to make sure I'm not, impeding any commercial vessels, or that turn in my track is going to be in the next 3 hours. So I can stay on this course for 3 hours and I don't have to make a turn for, a while. I don't have to be looking for a turn. Or something. It's just good for that projection, or that predicting. So kind of like I like to say on my car, if I reverse, it gives me a little sign. It gives me a little yellow, green, red of indication of where I'm going to be at a certain amount of time with speed, right? So a lot of your electronic plotters will give you that DR, and you could adjust it to say, in 15 minutes, this is where I'll be. And it gives you that little projection line, or in, 5 minutes, or in an hour. You can adjust it for whatever you want, but it's basically just a DR. So it's very helpful in the, electronic plotting world. But doing 60D street and plotting it on the chart is the paper way, and we are working on our paper plotting skills. So that is a dead reckoning position. It's just a calculated position. So what do we how do we put this on the chart? We need to know 3 things. We need to know a past position. So we have to have a starting point. So whether it's I departed that, NWP buoy at noon, or it was the last GPS fix I got, or the last visual fix I got, whatever it is, it needs to be a known position as our starting point. And you have a time that goes along with that. And then you have a course that since that starting point, I was on such and such course. I was headed in this direction at this speed. So whether you have, an average, you're an autopilot, you can say my average course here was, and my average speed was, whether you're logging every hour or every half hour what your speed is, so then you could average it out. If you have some sort of instruments on board to tell you what your course and speed are. so that you can put in from your known position what your course and speed is. We're basically just creating a vector. So we use that 60D street to get a distance, to put that distance on our course line, and we get a position. So let's look at an example of that. I have a track line here. So I have waypoint 1. Waypoint is just kind of a made up like intersection. And I've created, a street that track line that I want to stay on with another intersection with a turn. And I'm going to head for this buoy. So I wrote in my course and my speed. We're about 090 at 12 knots. And my course and speed on this leg is 040 at 12 knots. So at 7:30, I got a fix. I got an actual fix somehow, some way. This one is probably GPS. So I want to always project out a half hour or the top of the hour. That's a good habit to get into, to go to the top of the hour and then every hour or half hour after that, depending on where you are. If you're in congested waters, maybe you want to do it every 15 minutes, half hour. If you're in wide open ocean, maybe you want to do it every hour. So it depends on where you are. So in this case, if it's 7:30 and I want to project out where I'll be at 8, am I going to be past this turn? Am I going to be before this turn? Where am I going to be at 8 o'clock? Just a half hour away. So I use my 60D street to say if I'm going 12 knots, how far would I travel in a half hour, in 30 minutes? 6 nautical miles. So I measure out my 6 nautical miles and I put in a DR position. So this position looks a little bit different. It's going to be a semicircle. So it's just this like half circle. And then my time is going to be at an angle. It's not going to be straight, kind of like this fix is. Oh, there it is. I have an angle to my track line and it's labeled with a semicircle. So that way I know that this 8 o'clock is just a DR position. It's just a calculated position. It's not my actual fix. So I should be around here at 8 o'clock, but it's not an actual fix. It's not and we're going to talk about fixes next week using actual LOPs. But this DR is just purely a calculated position. But it is very important to plotting so that you can, make estimates and figure out where you're going to be. It's always good to plan ahead, right? So when do you plot a DR position? So it's a good habit, or the book says to do it every 30 minutes. Again, that's very dependent on where you are. I think every hour is fine when you go do it on the top of the hour. But it really depends on where you are and what's around you. You also want to replot your DR at any change of those 3 things. So if you change your course, you want to replot your DR. If you change your speed, slow down or speed up, you want to replot your DR. If you get a new starting point, if you fix your position or pass closely to a buoy or another aid to navigation, you want to replot your DR. So you want to plot it regularly, every 30 minutes to an hour. And then at any time those 3 elements change, my known position, my course, or my speed, I need to replot my DR. So that's when you plot your DR. Is there one thing? Oh yeah. So this I like to throw in here as kind of a hierarchy of fixes. Now again, next week we're going to dive more into what a fix is. But when we're talking about dead reckoning and it's just this calculated position, I don't want you to completely be like, oh, it's just a calculated position, don't need to know it. It is very valuable in your navigating. But it is the, I'm going to go with least accurate. It has the least amount of up-to-date information because it has this past position and then it has this average or assumed course and speed that we're making. So we're assuming we're making such and such speed. We're assuming we're making such and such course, where we don't know, you know, if I'm actually making that or not. If I had more information, I could get one of these fixes, but the dead reckoning, the DR fix has those assumptions built into it. So we just want to keep that in mind when we're looking at a DR fix on a chart to say, okay, there were some assumptions in that. I might give it a little more wiggle room. You know, I might be like, oh, if it's, you know, close to a danger or something, I might, you know, give more space to that danger so that I'm not, or like, oh, I'm going to make it by 1/10 of a mile. I might want to give it a little more space or something. So we have a dead reckoning position. We have an estimated position. An estimated position has one more piece of information, whether it be one LOP, that's a line of position, or another piece of information, such as a known set and drift. If I have a known set and drift plus a DR, I can have that adjusted DR and make it an estimated position. Then we have a running fix. A running fix, and we're going to go into this. We do a whole lesson on running fixes, I think, in week 6. One of the weeks, we do a whole lesson on running fixes. And a running fix is when we have two lines of position at different times. So we had a line of position, you know, 15 minutes ago, and then a line of position now. How can I use those two pieces of information to give me an accurate fix? It's called a running fix. And then we have our electronic fix, which is either a radar or GPS, typically, is what we're going to put on for our electronic fix. And then this hierarchy tells us that our visual fix is going to be our most accurate. I'm going to say these days, maybe an electronic fix might be a little more accurate, depending, right, on how comfortable we are taking sights with our compass, getting a visual fix. That can leave a lot of room for error or wiggle room. Sometimes the electronic GPS might get you a more accurate position, but sometimes your electronics might be a little bit off. They're, you know, all dependent on calibration as well. So I kind of flip-flop on electronic fix versus visual fix, but I don't know. That's my 2 cents on that. And then we are gonna, when we talk about running fixes, we also talk about a bow and beam fix. And I like to put that right in the middle between, it's better than a dead reckoning, but it doesn't have quite that solid piece of solid value, which again, you'll go into. I don't have my calendar. On one of the weeks. One of the weeks we dive into different types of position. So we are starting with dead reckoning today, that calculated position, that kind of base of our hierarchy of fixes. Any questions on that, or any questions so far? Okay.
Nope.
it's 8 o'clock. Let's take a 10-minute break. Let's come back at 8:10. And we are going to dive into assignment number 10. So that is your training chart, the Martha's Vineyard chart. And we are going to start with assignment 10. All right, I'll see you guys in 10 minutes. How's everyone doing?
We're good.
All right.
Okay.
Okay, good to hear. Well, we are going to get started on assignment number 10, our intro to DR plotting. So that's going to be on our training chart. So hopefully you guys can see the training chart. You guys have it out. And we're going to get started on it. Any questions on 60 D Street or time before we get started? Making sense? All right. So let's jump into it. Today's cruise will be from Newport, Rhode Island to Martha's Vineyard. So we're going, where are Newport? Newport next. Newport's up here somewhere maybe. Newport all the way over to Martha's Vineyard. So we're going to start at 8:20, departing Brenton Reef Light. I can't see it. So here's our Brenton Reef Light. We're going to use that a lot on our training chart. And then we are going to Buzzards Light. Let's see if I can fit both on the page. Okay, so we have Brenton Reef and Buzzards. We depart Brenton Reef at 8:20. Try to make that 8:20. And we're gonna head over here at a speed of 6.5 knots. So I want to draw the line on my chart and then put that information. So my first step is to just draw that line. So I'm going to use a ruler because it's pretty long. Try to make it a dark line so we could see it. So I have my line going from Brenton Reef to Buzzards. And I'm going to say that this is a certain course and a certain speed. So I need to measure my course. So at any vertical intersection, it's crossing 2. I'll line up my triangle. So my top of the triangle, or the long side of the triangle, is on the line in question. And then I have the focal point on a vertical line. And I'm going from Brenton Reef to Buzzards. So my number is going to be between 90 and 180 in that quadrant of the compass. So when I look at my numbers here, I have 090, 100, and I'm going to call this 9596. So I'm going to call this a course of 096 degrees true is my course, and my speed is 6.5. That's what they told us in the question. So along this course line, I'm leaving here at 8:20, and I am going to be making an average speed of 6.5 on a course of 090 true. Excuse me, 096 true. So that is just plotting the line and labeling it with a course and speed. Okay, so then it asked me some information before we plot our DR. It asks us what is the entire distance of this leg and what is our ETA. So it's basically asking us, you know, what is the ETA to the end? When are we going to get to buzzard's light at the end of this leg? So I need to calculate this distance. So I'm going to use, I can't do it in one swoop. So I'm going to find 5 nautical miles on my dividers and walk it over. So I'm going to go to the side of the chart here. And that's 5 nautical miles. So I'm going to start that on Breton Reef. And I go 5, 10, 15, plus some small amount. So I can say 15 plus, and then whatever this is, and I'll measure it here. So I have 1.12, we'll call 1.2. So that was 15 plus my 1.2 gives me a distance of 16.2 nautical miles on this leg. So just roughly, I want to put the distance in case maybe you slow to 5 knots or, you know, something happens along the way, whatever. You already have that distance measured and written down. So you already have the distance of this leg measured out and written down. You don't have to do it. So that's always good in your voyage planning. So I have my distance. I think I'm going to go 6.5. So what is my ETA? I have a speed of 6.5 knots, a distance of 16.2. What is my time? $60 times D divided by S equals T. What did you guys get for time? Okay. 60 times 16.2 divided by 6.5 gives me, let's make it 150 minutes. So 150 minutes is going to be equal to 2 hours and 30 minutes, right? Yeah. So I have 2 hours, 30 minutes, and I had a departure time of 8:20. So if I left at 8:20 and it's going to take me 2 hours and 30 minutes to get there, what is my ETA? do my minutes first. 50 and my hours 10. So my ETA is 10:50. Okay, so I think I'm going to be here. Make it a little DR at 10:50. Just calculated time. Okay, so that was an ETA calculation. Any questions on ETA? All right. Now we're going to put in our DR marks, our hourly DRs. So in this case, we left here at 8:20. So the next top of the hour is going to be 9. And then we have a 10. And then we're going to get to our buoy. So we have 2 DR marks to put along the way, a 9 o'clock and a 10 o'clock. So first step, I want to figure out how far I'll travel in 40 minutes to get to the top of the hour. So I'm going to use my 60D street and say I have a speed of 6.5. I have a time of 40 minutes. What is my distance? Let's do magic circle. So we have 60 times our question mark, 6.5, and 40. So the two things we have, we multiply. .5 times 40, divide by the other value, divided by 60. We have a distance of 4.3. So I'm going to find 4.3 on my dividers. So there's starting at 8:20, and where's my pencil? I'll be here at 0900. And then to do the hourly DRs, and I guess that's why I like to do the hourly ones, you can just use your speed, right? Because speed is nautical miles per hour. So in 1 hour, I am traveling 6.5 nautical miles. So 6.5 nautical miles per hour. I need to find 6.5. And then I can walk this 6.5 hourly DRs as long as I need to. In this case, I'll have one here. At 10. And then walk past, and I will be just past that Buzzards Light. So that makes sense that I'll be there at 10:50, not quite an hour. So I've plotted this distance was 4.3 and this distance was 6.5. How you guys doing on those DRs?
Okay.
All right. So now we have a new piece of information into the puzzle here that says we actually arrived at Buzzards Light at 10:35. So our actual fix I'll erase this guy. And I'll say our actual fix was 10:35. Make it so we can see it on there. So what was they're asking us using the actual time from 8:20 to 10:35, we traveled 6.2 nautical miles. What was our speed? So without calculating anything so far, was our speed faster or slower than the 6.5?
Faster.
Faster. We got there sooner. So in this calculation, we're calculating what our speed was, but it should be faster than 6.5. So to figure out our we have speed, distance, time. Our distance was the same at 6.2 nautical miles. We're looking for speed, and we need first to calculate our time. So our time was the difference between 10:35 and 08:20. We are subtracting these times. So 35 minus 20 gives me 15. 10 minus 8 gives me 2. So I have 2 hours, 15 minutes. And then I also need to convert that to minutes. So I have 120 plus 15 gives me 135 minutes. So there's a little bit of calculation there that we needed to do. But now we can put this into our formula. Did I do formula or circle last time? I don't know. We're looking for speed. So we have 60D divided by T gives me speed. That gives me 60 times 16.2 divided by 135 gives me our speed. What was our speed?
$7.2.
7.2. So that is quicker. Oops. That is quicker than our 6.5. So that makes sense on our does it make sense test. That our speed was 7.2. All right. Any questions on those calculations? We had a little bit of the time calculation and then the 60D street. Figuring out what our speed made good was instead of, you know, the assumed speed. Okay. Shimmy my camera. Okay. So then we're on number 7. We have another leg of our little cruise here. It says, after taking photos of all sides of the tower and fishing for a while, we end up departing the light at 10:56 for buoy 29, which is northwest of Gayhead. Locate this buoy and plot our new course. Our new speed is 5.6. So now we are going a little bit slower. New speed of 5.6, and we're heading to buoy 29. So what is that course and how do we plot it? So we're actually going to leave here at, just going to write this number, 10:56. Try to make it bold so we can see it. And we are headed for buoy 29, which is right here, right off of Gayhead Point. So I'm going to find buoy 29. Create my course line. Use my roll plotter this time. I want to put in what my course and speed is. So my course and speed, my speed was 5.6, but I'm going to find my course. So I'm going to use my roll plotter here, line up the black line of my roll plotter on the line that I just drew, and then bring it down to the compass rose. From the center, I will be doing 100, 105, so 104. 104 degrees true is my course, and my speed is 5.6. So I have a new course and a new speed. And I think I want to get the ETA. What is my ETA to the buoy? So in order to get that, I need to calculate my distance. Can I do it in one swoop? I think I can. I spread the dividers. Almost 8, so we'll call that a distance of 7.9. And if I had a speed of 5.6, what is my ETA? Departure time. What did you guys get for time? $85 minutes. That equals 1 hour, 25 minutes. I have 1 hour, 25 minutes. I departed at 10:56. I'm traveling for 1 hour and 25 minutes. 56. Let's do it here. 56 plus 25 gives me 81. But I can't do 81, can I? So I have to subtract my 60. I'm left with 21. I carried 1 over here. And I have 1 plus 10 plus 1 gives me an ETA of 12:21.
You know, I have a question.
Yeah,
Yes.
go ahead.
You know, when you leave Buzzard's light, we had already written a time on there, our ETA of 10:50.
Mm-hmm.
Now we're writing down the real time we left, which is 10:56. So when you write those numbers on there, there's no designation that that's time. It's just you write 10:56. Is that,
Correct. So when you write it next to a fix, like you have,
yeah, it's right next to the, so it's just a given that it's a time.
so yeah, you have a fix, whatever it is, and then you put a time next to it. It is just given that that's a time.
Yeah, this is right next to the light. Well, I guess it's our destination, so that's the fix. It's our
Yeah, because we're passing very closely.
Okay.
So other numbers that you might write on the chart, your 096 degrees true
Right.
has those units on it, and you can put in front of that CSE or just C if you want. You can just do a C for your course, and then speed, 10.0 knots. You have that unit next to it. Distance, whatever it is, 15.8 nautical miles. You have that unit next to it. And for these, you could say CSE. Sometimes I use SPD, and sometimes I use DIST, just
Okay.
as abbreviations.
Okay.
But for time, you just put it next to a fix, and that is the time. Any other questions with that one so far? Right, we are chugging along here. Oh, actually, okay, so this one gives us a little plotting exercise. Always good to go back to our plotting skills. It's asking us, what is the deepest water that you will have sailed over on either leg of the cruise? So we are looking, I know you can't see, but on either leg of the cruise, what is our deepest spot? So our deepest spot ends up, see if I can zoom in here, being right here. I'm going to draw this out real quick. Okay, so this is a poor basic drawing of of those sounding curves, or the fathom lines, I like to call them, even though they're in feet. All soundings are in feet on this chart. But we had a sounding north of the deepest number that we saw was a little bit north of the track line at 109. We had a 102. And then we had this sounding curve line that says anywhere on this line was 90 feet. And then anywhere on this line was 60 feet. The little 60 footer right there, a little bit deeper. So we could kind of see that, you know, it's getting shallower. You know, this area is shallower. This is kind of the deep valley, if you will. Kind of deeper. We had the 109. There was another 109 up here. 121 way up there. So it kind of gets real deep up in there, kind of getting shallower. So if we are right here on our track line, my answer was our deepest spot that we will see is 108 feet. And that's because I'm not quite passing over the 109. I'm a little bit towards the shallower end of towards 102, but pretty close to 109. So if you say 109, that's totally fine. But the reason I said on my answer sheet 108 is because I'm not actually passing over that 109 sounding, that it's a little bit closer to the shallower area. So that's why I did that. But then we're going to plot our lat and long. So in this case, we had our longitude line and our latitude line. So we practice our plotting, putting in our latitude and our longitude. And again, for this, if you don't want to put the whole line across, you can just put a little tick. You know, do the shortcuts that you're comfortable with, but you want to make sure that's a paralleled latitude line and a paralleled longitude line. Any questions with this one? Making
Hey,
sense?
Bruce Herman,
Yeah, go ahead.
you see where you have the topography lines? Usually
Yeah.
when you have a 60, they normally, that contour goes right there and they cut it, right? And they put the number there?
Are you talking about this line?
Yes. So that's a 60. Usually when they have the 60, they have it cut, don't they? And they put it in between?
They have it cut. What do you mean
They have
by
like a
that?
space,
Oh, like
yes. And then they'll
like
put,
that? or
well, no,
something?
just one space and then the number there.
One space and then the number.
You see how, when you see the contour map?
Yeah.
And it's cut and they write the number there?
Yeah.
That's the whole line of the contour right there, right?
Yeah. So they're saying this
They
whole
don't-
line,
okay. Yes,
they're saying is 60.
Yes,
And it kind of
There you
goes
go.
like that.
yes,
Everywhere along that line is 60.
correct. Okay, I just want to make sure. Okay, thank you.
Yep.
Oh, I see. Okay.
All right. So we arrive at buoy 29 at 12:15. So our actual fix we arrive at 12:15. So are we going to go, are we going faster or slower than our 5.6? Faster. Well, let's figure out what our actual speed is. So we are looking for speed. Our distance was the same at 7.9. Our time is going to be that time difference between when we arrived at 12:15, when we got to buoy 29, and when we departed at 10:56. So what was our transit time? (15 minus 56). Can't do that, so we'll make that 11 and a 75. 75 minus 56 gives us 19, and 10 minus, or 11 minus 10 gives us 1. So we have 1 hour, 19 minutes, and I need to convert that into minutes so I can put it into my 60 D Street formula. So I need to 60 plus 19 gives me 79 minutes. So let's mix it up here, do magic circle.
Oh, yeah.
We have 60, distance was 7.9, speed is our question mark, time 79. What was our speed? Right off the bat, we know our speed is 6 knots. So yes, that makes sense that we're going a little bit faster than our 5.6. Speed was 6.0. All right. Again, we're just practicing our time calculations and our 60 D Street. Okay, now we're going to continue on our little course leg here to Martha's Vineyard Pond. So they say to finish the trip, label and lay a course to buoy 1, the entrance of Minmasha Pond. I don't know how to say it. Our speed is still going to be 5.6. So even though we got an updated speed made good, we're still going to aim for 5.6. So what is the course? What is our ETA? And what would be the total time elapsed of this trip? Okay, so where is our buoy 1? So this is that same buoy that we've used before. It's hard to see because that one looks kind of like it's part of that fathom curve, that line, but it's this little black buoy that says Bell. That's our buoy 1. Try to zoom in here. The focusing. Okay, so there's our buoy 1. So we will make our line from buoy 1 from buoy 29. And as I'm making this line, I see that I'm going to pass real close to this other buoy, this can buoy C. So just so I'm aware, I'm going to be passing close to that buoy. Take note. But I am headed to buoy 1. So what is my course line? You can use the triangle. I haven't done the parallels yet. So let's do the parallels on this one. We have putting our course line that I just drew on the black line, and then I'm going to walk one ruler of our parallel rulers down to the center of the compass rose here. Put it on the center of the compass rose. I'll draw my line. And I have a course of 096. So 096 degrees true. So we could see 090, 095, and then 1, so 096. So that is my course. Let's see. What is I have my speed of 5.6. And I also need to write in my distance. What is the distance of this leg? So I'll use my dividers. One on the buoy 1 and one on buoy 29. I got a distance of 4.2.
Yeah.
4.2 nautical miles. So if we go to our whiteboard, we have a speed of 5.6, a distance of 4.2 nautical miles. How long will it take us? Let's plug it in. So we have 60 times D divided by S equals T. Plug in those values. 60 times 4.2 divided by 5.6 gives us a time. What was your time? Okay, I'll do it. 60 times 4.2 divided by 5.6 gives me 45 minutes. So I have a time of 45 minutes. So if it takes me 45 minutes to travel along this leg, what is my ETA to buoy 1? So this one you could pretty much do in your head, but we have our departure time was 12:15.
Oh.
Our
Where,
transit time,
where does it say departure time of, oh, you arrived there at 12:15. Okay. I follow you. Thank you.
okay.
Yeah.
We had our transit time of 45 minutes. So our ETA gonna be 1300. Okay. So then it says on our last question is just a question on time. That says, what was the total time of the trip? What was our total time underway? So if we arrived at the pond at 1300 and we departed Brenton Reef Light at the beginning of our voyage from Brenton Reef Light at 0820, what was our underway time? How long did we spend underway? Oh, we always go with our minutes first. We can't do 0 minus 20, so we have to borrow from the 13. So we'll make that a 12 and this a 60. So we have 60 minus 20 gives us 40 minutes, and our 12 minus 8 gives us 4 hours. So our total time underway was 4 hours and 40 minutes. Okay. So that was assignment number 10. Where's our plotting? For the homework this week is again just practicing those 60 D Street skills. So again, 10 kind of little word questions, word problems of 60 D Street. Of, you know, you have a missing value in that speed, distance, and time equation. So so it's really going to become, you know, hopefully that second nature, if you will, just kind of that, yeah, second nature. Hopefully you can almost do most of it in your head, or not the calculations per se, but that common sense check, you know, does the number I get make sense for how many, you know, nautical miles per hour? just to do that double check of, yes, this number makes sense, that I'm not going, 42 knots or something when I'm really going 4.2 knots or whatever it is. So you always want to do that double check. All right. Any questions on speed, distance, time? All right. Next week, we're going to do LOPs. What are we doing next week? We're doing LOPs and fixes. So we're going to put together kind of last week and this week and put it into plotting. So we'll look forward to that. Hopefully I will be here. I would say it's probably going to be my last week next week, and then Robert's going to take over. So be aware or be on the lookout for that email from him to get a new Zoom link. And if you guys are interested in CoNav1 please sign up for that. It's a great addition to this course. It really builds on your plotting skills. So totally check that out. You guys have any questions for me? I know we kind of wrapping up early here.
That was good.
Can you do this just a real quick? That 096, can you just put up the chart we just worked on? And the first leg, show how the 096, where you put the dot and what, how you position this.
Yep. Okay.
The first, are you on you're going to do the first leg, the 096?
Oh, we ended up having two 096s. The first leg?
Yeah.
Okay. Having trouble focusing this.
It's clear.
Okay. So there we go. We have our course line. We went from light to light.
Uh-huh.
And we have it crossing through two vertical lines.
Okay.
So we could use either one.
Okay.
I guess I'm just going to use this one. So I'm going to put that focal point on a vertical line. And then the line that I drew on this black line, that's like a half inch.
Going. So you put, okay, then you put the line, okay, I got it. And then you put the circle on that crossing point, okay. Okay, and then you just, can you point? Then there's the 096. You follow the same line down, right?
Yep, so you're following that vertical line down.
Okay.
And where does it cross the triangle?
Okay. Okay. This one has big hash marks. It looks like it's right on 095. It's kind of weird. Okay. Or maybe I'm not. Okay. All right. I'll play around with it then.
Okay.
Okay. So you put the circle where they cross, the little hole where they cross, and then you put you follow the course line.
Correct.
Edge. Okay. I'm going to take a picture of what I just did. I'll take a picture with my phone, then I'll remember. Okay. Got it. Thank you.
No problem. All right.
Where's my phone?
Well, that's all I got for you guys tonight. I will, this is being recorded, so I will upload this tomorrow. If you guys want to look it over on the weekends or whenever. It'll be posted for you guys. And that's all I got for you guys.
Thank you, Bree.
Thank you.
Thank
You're
you.
welcome.
All right. Thanks,
Have a good
Bree.
weekend.
Hope to see you next week.
I hope to see you next week too. Kind of. I kind of just want this baby to be
Yeah.
dead.
Okay. Bye-bye.
All right. Bye, guys.
Bye.